The world has changed a lot in the past 1,000 years, but for most of that time, one thing remained the same: the amount of carbon dioxide in the atmosphere. But in the late 18th century, this happened, and the levels began to climb.
And then in the 20th century, it goes through the roof. It goes to levels that it's not been seen at in nature for millions of years.
The increase in atmospheric carbon is the biggest contributor to climate change, the key to reversing the damage, restoring Earth's delicately balanced carbon cycle. The way carbon moves around the Earth is known as the carbon cycle. It consists of sources, which emit carbon into the atmosphere, and sinks, which take carbon out of it.
The biological side of the carbon cycle is pretty near perfect.
It works like this. Respiration, for example when animals breathe, emits carbon dioxide into the atmosphere. Then plants, bacteria and algae take CO2 out of the atmosphere during photosynthesis, the process they use to generate chemical energy. Oceans are both sources and sinks.
Carbon dioxide is endlessly being absorbed into the oceans and released from the oceans at almost exactly the same rate. The system naturally balances itself out. If there's more carbon dioxide being drawn down into the biosphere, then more carbon dioxide will be pushed back into the atmosphere. If the atmospheric level of carbon dioxide goes up, the levels by which it's absorbed by the oceans and the plants will go up too. It's in what scientists call a dynamic equilibrium.
But a few hundred years ago, this dynamic equilibrium was knocked out of kilter. When organisms die, some of the carbon stored inside them gets buried underground, stopping it from going back into the atmosphere. For hundreds of millions of years, this fossil carbon was left mostly undisturbed, until humans started to dig it up and burn it as fuel. The way humans have changed the carbon cycle is one of the reasons some scientists say the Earth has entered the Anthropocene, the geological age when human activity is the dominant influence on the environment. Today, fossil fuels add an extra 9.5 billion tonnes of carbon into the atmosphere.
Think about all the petrol that's poured into all the cars in all the cities in the world. Think about all the coal that's going into all the power plants in all the countries in the world. Think about all the gas that's being burned on all the burners of the stoves of the whole world. That's what gives you 9.5 billion tonnes.
Roughly half of this extra carbon from fossil fuels is absorbed by the Earth's sinks, but the rest that makes it to the atmosphere traps heat, warming the planet. This has had a devastating effect on the world's climate. It also changes how well carbon sinks function.
This is where things get complicated and scary. As temperature changes, the environment changes, and that may not be good for the sink. In the ocean, cooler water absorbs more carbon dioxide. So as the oceans warm up, their ability to absorb carbon dioxide goes down. Plants photosynthesize more if there's more carbon dioxide, which you would think is good. But plants synthesize less if they're dead. And if the climate changes so that a large number of plants die, the photosynthesis of the planet will go down.
Human action took a sledgehammer to the Earth's delicately balanced carbon cycle. The damage is not irrevocable, but only humans can fix it.
The first thing to do if you want to get the carbon cycle back into a stable balance is to stop pushing it. That means reducing human emissions from fossil fuels as quickly as you can.
Climate change has got to go! Hey, hey!
The growing green movement proves there is an appetite for that, but emissions aren't being cut as severely as they need to be.
At very best, you could say that the rate at which carbon emissions from fossil fuels has grown has maybe slowed a little bit.
The international politics of climate change makes cutting carbon emissions particularly difficult. You can find out why by clicking on the link above. But even if humans stopped using fossil fuels and carbon emissions were zero, the amount of carbon in the atmosphere would not return to pre-industrial levels. It would just stop growing. To bring atmospheric carbon levels down, humans need to build systems that either create a new sink or amplify the actions of an old sink. These are called negative emission schemes.
In terms of amplifying an old sink, you might restore a forest that had been degraded. You might change the way that you run pasture land so that the soil stores more carbon. In terms of a new thing, you might actively suck carbon dioxide out of the atmosphere and pump it back down into geology.
This is known as direct air capture. Mechanical systems suck carbon dioxide out of the atmosphere. The carbon is then either stored underground or reused, for example, to make fuel or to make new rock. Negative emission schemes work well to offset some of the carbon humans emit. But when it comes to rebalancing the carbon cycle, they're not a perfect solution.
If you concentrate on negative emissions, then you're kind of giving yourself license to go on polluting, and that's something that is a very dangerous trend. Second problem with negative emissions, they are relatively inefficient. Pulling tens, hundreds of billions of tons of carbon out of the atmosphere through industrial means is a massive undertaking.
The negative emission schemes that are being developed today work on a very small scale. In order for them to actually have a positive, lasting impact, the world's economic structure would need to change drastically.
It's like running the whole fossil fuel industry in reverse and then some. That's why relying on them when we have nothing like the sort of like infrastructure or economic incentives or history to know that we're going to do them is such a dangerous idea.
At some point, humans will stop burning fossil fuels, either by choice or by force. By the time that happens, the world will look very different to what it does now. It took just a few hundred years to destroy the dynamic equilibrium of the carbon cycle, but it'll take many hundreds more to restore it.
I'm Oliver Morton. I'm the briefings editor at The Economist. We've written a series of climate briefs to cover the basics and a bit more than the basics on all sorts of aspects of the climate crisis that's facing the Earth. You can read them all at the link opposite. Thank you for watching.